Every year, deep inside one of the most complex ecosystems on Earth, something begins. It doesn't start with noise. There's no sudden chaos, no dramatic signal that something has changed. In fact, if you were standing there, you might not notice anything at all. The forest would feel the same, dense, humid, alive in that quiet, overwhelming way. And yet, beneath that stillness, thousands of animals are already moving. Not randomly, not slowly figuring things out, but with precision, with timing so exact, it almost feels coordinated. And here's the part that doesn't quite sit right. No one has ever fully explained how they know when to begin. If you're into mysteries like this, where nature doesn't quite follow the rules, stay with me. Because this is just the beginning. At first, it seems simple enough. Scientists will tell you that migrations are driven by survival. Food shortages, seasonal changes, breeding cycles, basic biological needs. And on the surface, that explanation works. Until you start looking closer. Take the Amazon rainforest, a place so dense, so layered, that even sunlight struggles to reach the ground. Visibility is limited. Movement is difficult. Communication, at least in the way we understand it, is nearly impossible across large distances. And yet, somehow, animals spread across miles of thick jungle begin moving at almost the exact same time. Birds that haven't seen each other in months suddenly shift direction. Insects emerge in synchronized waves. Fish begin traveling upstream, navigating waters that have changed since the last time they passed through. No central signal, no visible trigger. So what are they responding to? This is where things start to get uncomfortable. Because the more researchers study these patterns, the more they realize that the obvious answers don't fully hold up. For example, environmental cues. Changes in temperature, rainfall, daylight. These are often cited as the primary drivers. But here's the problem. Those changes aren't always consistent. In some years, migrations begin before significant environmental shifts occur. In others, they're delayed, even when conditions appear identical. So the question becomes unavoidable. If the environment isn't giving a clear signal, what is? And this is where most explanations stop. But if you want the full picture, you have to go further, because what comes next starts to blur the line between instinct and something far less understood. Let's talk about timing. Not just general timing, but precision. There have been documented cases where certain species begin migrating within a window of just a few hours across regions separated by vast distances. Not days, not even a full day. Hours. Now think about that. These animals aren't communicating through phones or signals we can detect. They're not checking conditions across the forest before making a decision. And yet, they act as if they already know. It's almost as if the information they need isn't being received in real time. It's already there. Some researchers have suggested internal biological clocks, genetic programming that tells animals when to move. And again, it sounds reasonable, until those clocks don't match up. There are cases where animals adjust their migration timing in ways that shouldn't be possible if they were strictly following internal rhythms. Sudden changes, unexpected shifts, as if they're responding to something external, but not something we can easily measure. And this is where things get even more difficult to explain. Because the deeper you go into these patterns, the more you start to see something that doesn't quite fit into traditional science. Let me give you an example. In certain regions, large groups of animals begin moving before a major environmental event, like flooding or drought, even when there are no immediate signs that such an event is about to happen. No visible changes in the sky, no detectable shifts in temperature or pressure. And yet, they move. Not all of them, not every time, but enough to make you question whether it's coincidence or something else. What would you do if you saw that happening? If you noticed animals around you leaving before anything had changed? Would you trust your own senses or theirs? Because here's the unsettling part. In some cases, the animals that leave early survive, and the ones that stay don't. Now, of course, there are scientific attempts to explain this. Subtle environmental cues that humans might not detect. Changes in humidity, ground vibrations, chemical signals in the air or water. All valid possibilities. But even when those factors are accounted for, the precision and consistency of some migrations still don't fully add up. It's like trying to solve a puzzle where a few key pieces are missing. And without those pieces, the picture never feels complete. Let's shift focus for a moment. Because it's not just about when animals move. It's about how they move. Navigation, in itself, is another mystery layered on top of everything else. Birds traveling thousands of kilometers without losing their way. Fish returning to the exact stream where they were born. Insects crossing continents with no prior experience of the journey. And they don't just get close. They arrive with accuracy that feels almost impossible. Scientists have identified several mechanisms that might explain this. Magnetic fields, the position of the sun, even the stars. But here's where it gets complicated. In dense environments like the Amazon, many of these cues are either blocked or unreliable. The canopy covers the sky. Light is scattered. Magnetic fields can be distorted by geological variations. So how do these animals stay on course? Some studies suggest they might be using a combination of cues, layering different sources of information to create a more reliable sense of direction. But even that doesn't fully explain the level of precision observed. It's like they're following a map that we can't see. And maybe that's exactly what's happening. Not a physical map, but something embedded deeper. A kind of inherited knowledge that goes beyond simple instinct. Now, before jumping to conclusions, it's important to stay grounded. There's a tendency to romanticize these behaviors, to turn them into something mystical or supernatural. But that doesn't help us understand them. At the same time, dismissing the gaps in our understanding doesn't help either. Because those gaps are real. And they matter. They're the difference between what we know and what we assume we know. Let's go back to the migrations themselves. There's a pattern that shows up repeatedly across different species and environments. Synchronization. Not perfect, not universal, but consistent enough to stand out. Groups moving together, even when separated. Events happening in sequence, as if coordinated. And sometimes, behaviors that seem to anticipate changes before they occur. It's subtle, easy to overlook if you're not paying attention. But once you notice it, it's hard to ignore. And this is where the idea of collective behavior comes in. The concept that animals, in large groups, can act as a kind of distributed system, processing information collectively rather than individually. It's been observed in flocks of birds, schools of fish, swarms of insects. Each individual following simple rules, but together creating complex, adaptive patterns. That explains movement within a group. But it doesn't fully explain coordination between groups that aren't directly interacting. And that's where the mystery remains. Because if these animals aren't communicating in ways we understand, and they aren't relying solely on environmental cues, then what connects their behavior? Is it purely biological? Is it environmental in ways we haven't measured yet? Or is there a layer of interaction, something subtle, something indirect, that we're only beginning to recognize? There's no clear answer. And maybe that's the point. Because not every pattern in nature has been fully decoded. Not every behavior has been reduced to a simple explanation. And migrations, especially in complex ecosystems, sit right at the edge of what we understand. They're predictable enough to study, but unpredictable enough to keep us guessing. And that tension is where things get interesting. Because it forces a question that goes beyond wildlife. How much of what we see in nature do we actually understand? And how much of it are we just comfortable explaining? There's a difference, a significant one. Understanding means you can account for the details, the inconsistencies, the exceptions. Explanation, on the other hand, can sometimes be a way of simplifying something that's still incomplete. And migrations, these quiet, precise, almost coordinated movements, feel like something that hasn't been fully understood yet. Not completely, not in a way that answers every question. And maybe they never will be. Because nature doesn't always reveal its patterns in ways that are easy to interpret. Sometimes, it shows you just enough to recognize that there's more beneath the surface. And then it leaves you there, thinking. If this made you question how much we really understand about the natural world, stay curious. Because there are patterns out there, subtle, consistent, and still unexplained, that most people never even notice.